Inverse functions, identifying if two functions are invertible. So when given two functions, you're going to have two routes that you can go about doing this. One of which is you can actually just rearrange the given function or one of the given functions to switch the x and y and then solve for y all over again. What that's going to do is switch your input and output, and then it's going to also allow you to solve for a new input output versus the opposite of what the original function was. So there's also another way to do it. The algebraic correct way would be embedding a function within another function. So anytime you have embedded functions, so like the function of g of x, so the function of f of g of x would be g of x being embedded into the function of f. So let's go ahead and take a look at that. I'm going to show both ways on how to do it. You can see here that we have f of x equals the cube root of x plus 2. G of x equals the quantity of x minus 2 cubed. Well, the first thing we're going to do is we're going to plug in g of x into the function of f of x. And then we're going to solve and figure out what we get there. So we know that we have the cube root of, and we know that g of x is going to fit in for that x right there. So I'm going to go x minus 2 cubed, and then we still had that plus 2 in the original f of x function. Now I'm going to simplify. We know that a cube root with a cube inside of it is going to cancel each other out. They are of equal and opposite power. That's going to leave us with x minus 2 plus 2. Simplify even further. That minus 2 and plus 2, those are going to end up canceling each other out. Anytime you add opposites, you always end up with a zero pair. So the function of g of x, when it's embedded inside of the function f of x, is going to give us x. Now we have to do the reverse. So that's exactly what we're going to do. So now we have g, the function of g, with f of x substituted inside of it. So now we're going to solve this and see if it comes out to be the same thing. If it comes out to be the same thing, then we know that we have invertible functions, and these two, f of x and g of x, are going to be inverted of each other. So let's start with, we know that we're going to substitute f of x in for x on g of x. So that's going to be cube root x plus 2 minus 2, and that is going to be cubed. Okay, so now we kind of have something similar going on. We're going to have a cube and a cube root, which are going to cancel each other out, giving us x plus 2 minus 2, and those cubes are gone. So now we kind of run into the same bit we had before. Create a zero pair. We got x. So now we have established that whenever we substitute a function in for the other function, we know that they come out to be equal. So this would be a yes. Is f of x the inverse function of g of x? Answer is yes. Now let's take a look at the other route that you can take in being able to solve for this. I'm going to go ahead and do that on the second example. So you can go ahead and substitute f of x and g of x in for each other and then solve and find out if they're equivalent or not. You can also take one of the functions. I'm going to take f of x and swap the variables like we have been on the graph, taking out information, turning it into a table, swapping x and y. First thing you're going to do is rewrite it as y equals x plus 9. And what an inverted function is saying is that the x and y values have been switched, and now we need to solve for y all over again. So that's what I'm going to do. I'm going to rewrite this as x equals y plus 9. I swapped them. Now we got to solve for y all over again. We can do that by solving a simple one-step equation. Minus 9 minus 9. That's going to create a zero pair, y equals x minus 9. Now what you can see here is y equals x minus 9. Is that the other function? No, the other function is negative 4x minus 8. So the answer to this one would be no. These are not inverse functions of each other.